So, good afternoon, everyone, and thank you for joining us today for this Solve It session webinar. My name is Rachel Sharman from Belzona's marketing team.
And I'm Ian Wade from the global support team.
And for this Solve It session, we are focusing on microporous membranes. We have a 20-minute presentation now, which includes an application demonstration. And then afterwards, we'll have a 10-minute Q&A session with Ian and Belzona's Engineering Services Supervisor, Henry Smith. So if you have any questions throughout the presentation, please do type them into the chat and we'll get to them at the end. So what are we covering today? Firstly, we'll look at what exactly is a microporous membrane. We'll look at the problems which plague roofing, before looking at where else microporous membranes can be used, because although they were traditionally designed for roofing, they can be used in numerous applications. Then we have that practical demonstration of how to apply a membrane before moving on to our question and answer session.
So to begin with, we just want to clarify exactly what we mean when we talk about a microporous membrane. A membrane is a selective barrier that allows the passage of certain vapors but restricts others. If the membrane was not microporous, any trapped moisture would have to find a different way out. But in the meantime, it could cause dampness within a structure and weaken them. The microporous membranes have been designed to prevent water ingress, but allow the roof or structure to breathe. As you can see in the slide, the membrane is preventing any water from penetrating through the membrane. But its microporous structure allows any trapped water vapor to escape through the membrane and reinforcing sheet.
So now that we've established the qualities of a microporous membrane, we want to look at why people are increasingly choosing this sort of technology, where are the main places they're used, and how exactly they help to seal and prevent leaks. So firstly, by using a microporous membrane, you are protecting an interior from leaks, whether that's protecting people, electrical equipment, other liquids, the list goes on. Or if a structure is already experiencing corrosion, membranes cut off the water supply and allow any remaining vapor to escape, just like Ian was saying. Ultimately, microporous membranes are used to repair and prevent damage. But to be a bit more specific, we're going to look at these areas where these systems are most often implemented. And starting with roofing. This is one of the most popular places where our membranes have been used for decades. So sometimes it feels like, especially on flat roofs, the potential for problems is almost impossible to avoid. On a flat roof, any rain can easily start to pool, and even if there are gutters or a slight incline to try and prevent it, this may not be enough. The weight of pooling water can lead to deflection and subsequent issues, and as you could have seen in the video at the bottom of the screen, even if it seems like the original membrane is protecting a roof, if it is disbonded from the substrate and subjected to localized damage, water can collect underneath.
So in our decades of experience, we have found that 90% of roof problems are actually only found in 10% of the areas. How did we come to this logic? If you think of a flat roof, which has an air conditioning ducting coming through the roof, where is the weak point in the roof? Any ideas? Yes, it's the ducting. So the troublesome 10% include skylights, joints and seams, protrusions, glazing bars, and gutters. We've included some before and after examples of the damage these areas can experience and how they look after being protected with a microporous membrane. So if we look at joints and seams, all the movement of a building is concentrated at the weak points. These can occur either between two separate parts of the building or two dissimilar building materials. Therefore, when a leakage occurs, its origin can be generally traced back to its weak points. So a flexible solution would be ideal in this repair. In this picture, they purposely chose a membrane like this because it could be used for just the joints and they didn't have to coat the whole roof. For protrusions, anything that penetrates through the roof needs sealing. In this case, a pitch pan or exhaust vent. Almost all sealers used will eventually crack due to loss of plasticizer or aging. If it is not stabilized or repaired, the vibration or movement of the penetration can cause the sealant to crack. The sealant used at metal penetration flashings eventually deteriorates with exposure, and it may not seal if the flashings have not been correctly cleaned before installation. They may also leak if the wrong diameter flashings have been used or the cover is not correctly installed. How to combat this? A flexible membrane that can adhere to different materials and be applied to complex geometries. Glazing bars and skylights generally fail because of the sealant. The problem is made worse due to movement of natural expansion and contraction of the roof. The conventional repair would be to remove all of the dried out sealant and replace it. However, this will not solve the problem as it will happen again and again. In both cases, we have two dissimilar materials with movement. A liquid applied membrane can give great adhesion to different substrates, but also offering watertight and weatherproof properties. Gutters are obviously designed to contain water, which run off the roof surface. Gutters do tend to leak at the joints, through bolt holes, or at the junction of the gutter and the downspouts. A general repair would be to rip out the old gutter and replace it. Or a microporous membrane can be applied to create a seamless transition from the roof into the gutter, preventing any water ingress between the gutter and the roof.
Perfect. And as we earlier mentioned, though, it's not just roofs which you can use membranes to repair and protect. On the screen are some of the other areas where they've been used over the years. We're just going to quickly look at the problems which can affect these areas and why you choose to use a membrane. So starting from the left, electrical inspection boxes, which have been incorrectly sealed, can cause costly damage to electricity and gas utility companies. This is due to water ingress into the electric components through failed seals. Then, if you look at this offshore crane, you can see an example of how the harsh environment of the offshore industry can cause leaks. Again, this has the potential to create electrical damage, which can put the cranes out of action for weeks and cost the platform thousands of pounds. Finally, HVAC systems. These are often left unmaintained and put under enormous strain, particularly in the summer and winter months. The joints and seams of air conditioning ducting can become loose and damaged over time, particularly at areas such as elbows and T-pieces.
For transport, installation of specific furniture into trains can cause cracks and holes in the train roof. This can cause damage to all internal fittings, which would be costly to replace and wouldn't be an enjoyable journey for passengers, especially if the roof was not weatherproofed. Above ground storage tanks and their contents are extremely valuable assets that need to be protected. Storage tanks can be exposed to extreme weather and operating conditions such as rain, heat, and loading. Conventional sealing methods such as mastic tapes are subject to shrinkage and UV attack, which do not allow moisture to escape. And hopefully you can remember from the wind turbine maintenance Solve It session, as the actual turbines and blades increase in size, ensuring the stable foundations of these structures is essential. Therefore, any defects in the base must be quickly rectified before failure, or even better, prevented. So just to look into this in more detail, tank bases are obviously one of the key areas where a microporous membrane can be utilized, and we have a long history of applications. Storage tanks are generally placed onto a concrete pedestal with a bed of sand. The tank can move, causing the conventional sealant to fail between the tank and the base. Over time, this results in corrosion at the chime angle, annular ring, or on the track underneath the base highlighted in yellow, due to either water ingress, poor drainage, or sloping foundations. And in the long term, it could cause loss of containment. How can we prevent this? Hopefully you're all shouting a microporous membrane. But our solution is to apply a microporous membrane onto both the concrete base and to the steel tank, with addition of bridging tape to allow smooth transition onto both substrates. The solution can also be inspected with NDT equipment. As well as tanks, roofs, and everywhere else, membranes can be used on pipework. This is to prevent corrosion under insulation, or CUI. As you can see from the picture, CUI is often unforeseen and it can potentially cause equipment failure. So it is essential that pipework and vessels are inspected regularly for this. Traditional metal cladding materials have inherent weaknesses at joints. These can be damaged by mishandling and impact. For example, workers walking across pipes damaging the protective cladding, as you can see in the top picture. As a result, this causes further gaps between the joints, increasing the risk of water penetration. If there is any water present, then ideal corrosion conditions may be created within the insulation layer, as a rock wool or foam glass can absorb the moisture. The result could be general corrosion across the surface of the equipment, or even more seriously, localized pitting equipment. Corrosion can occur with consequent premature failure of the equipment, so it is important to protect the insulated pipes. The microporous properties mean that it's ideal for applying to insulation. It allows any moisture from underneath and inside the insulation to escape, but at the same time prevents any water penetrating through. The membrane can also be cut to create a hole for inspection purposes, and then resealed with an additional layer of membrane.
Brilliant. So now we've spoken about what microporous membranes do, we just want to look at how they work. So fundamentally, you use a membrane to encapsulate a problem area, sealing it and protecting it. And this is rather than just patching it up, for example. Plus, because these membranes are liquid applied, you can use them on even complex geometries. And as well as this, thanks to the reinforcement sheet that you can see in the middle, they are able to flex with the substrate beneath. But rather than just telling you about how to apply it, we're going to go to Belzona TV, where we have this live application demonstration that Ian's going to walk us through. So that will be starting shortly.
In this video, we'll be showing you how to repair a leaking roof. For this application, Belzona 3121 MR7 emergency roof repair material will be used. As you can see, the two-part components are easy to mix, and because of its low odour, no special PPE is required. And the building, whether it's a hospital, chapel or university, can stay in operation during application. The great advantage for this material is that it can be applied even during adverse weather conditions, with no need for conditioning or primers. The material adheres strongly to all common roof surfaces, such as felt, asphalt, lead, glass, concrete or brick, and will cure at low temperatures. The reinforcement sheet within the material allows it to adapt to any roof movement. As you can see, as soon as the material is applied, the leak stops and becomes water resistant. For long-term protection of the seams, we'll be applying Belzona 3111 flexible membrane. This is a more cost-effective solution, protecting the troublesome 10% areas. This solution requires 2 coats and should be applied in alternate colours to facilitate misses or pinholes during application. Under good drying conditions, 30 minutes after application, the system will become water resistant.
Perfect, thank you for that, Ian. So that was a sneak peek from our membranes video, which will be live on our YouTube channel next week. That's youtube.com/Belzona TV. And as it was part of our Put It to the Test series, which we have on our channel, where we compare Belzona materials to more traditional repairs. But this is one of the types of the videos we create There were also application examples, product-specific videos, ones from the field, hundreds. So if you're interested in seeing the full video or any of the others, remember to subscribe to Belzona TV on YouTube. Now we're going to look at some examples of where these membranes have been used around the world.
So if we look at this case study from Poland, remembering the 10% troublesome areas we mentioned earlier, this is exactly the case here. In this situation, as only the skylights required repairing and not the whole roof, they were suffering from deteriorated sealant, and every time it rained, it leaked into the offices below. The solution was to apply a two-coat membrane, incorporating a reinforcement sheet to the joints between the skylights and roof. The next time it rained, the customer found no leaks and was happy with the application.
This application took place in France at the beginning of the year. Unlike a typical repair using a membrane, this time the material was required to protect this new build structure from any potential damage. They used Belzona 3111 on the roofs and walls of these three curved buildings. And after that, they used an adhesive to bond the little white tiles onto the outside of the buildings. You can see an example of this in the top right-hand picture. So the final look was these white tiles all over the buildings, but they were also waterproof and weatherproof thanks to the Belzona 3111 underneath.
So this one's from our friends over in America, a wind turbine base. Rainwater and moisture seeped into the ground and then into the wind turbine structure through the base between the tower structure. This over time affected the concrete base with propagated cracks and corrosion at the base of the tower beginning to occur. In this case, the current coating failed due to UV degradation leading to delamination of the concrete surface. The customer could have used a type of concrete filler, but needed extra flexibility in that area, so decided on a Belzona solution to seal the base of the structure. Belzona 3111 was a great and easy way to seal the base between the structure and the concrete. The application was so simple to do and proved to be a cost-effective solution with minimal downtime and interruption to the operation of the turbine.
And finally, this is a tank-based sealing application where, although there was an existing system in place, it had failed due to its rigidity. This had resulted in water ingress, causing corrosion at the base of the tank. Therefore, Belzona 3111 was used to provide waterproof protection at this base of the tank. And 3 years after inspection, in 2007, it was found to be in perfect condition with no signs of corrosion. Then it was re-inspected in 2017 and still found to be in perfect condition. So, all in all, the customer was very pleased with the application and its longevity in service, especially since, unlike competitor systems, it is possible to inspect the thickness of the annular ring through Belzona 3111. So those were just 4 of our Belzona case studies, but as you can see on the screen, we've actually collected over 2,500 at khia.belzona.com, which is our global case study library. It's actually the 4th largest in the world, so if you visit the website and type in some keywords, you'll always find applications relevant to you. We hope we've given you a good overview of some of Belzona's microporous membranes. If you want any more information after our Q&A session, you can check out our website, www.belzona.com. There, you'll find links to your local Belzona distributor, and as you can see by the map, we are well represented all around the world. But regardless of whether there's a little flag in your country, there'll always be someone dedicated to helping your region with our materials.